Part 2. Testing for Quality Assurance. Oh yeah, fun stuff to see over here. So, fasteners, and look at those screws. Wow. Just even the elements of the system is something that I don't...
So these are all the fasteners that we use to go through. They go all the way through the panel into the supports. Obviously this one's too long, but depending on the thickness of the panel, we use a different screw length. They have about 3 inches of thread, but you know, with these particular screws, about an inch, inch and a half is usually what is the design factor for the fastener.
So the length of the shaft is really just going through foam, right?
It's just going through foam, yeah. So if this were, well, this might actually work. If this was a full panel, now it's a little short, but realistically all it does is go through, and having the larger pancake head, it keeps it from penetrating or ripping through the OSB. So,
and then it connects into something dimensional at the other.
Either into a piece of wood, a piece of steel. We have fasteners that'll go into both light gauge steel as well as up to 1/4 inch thick steel members if needed. So they can be used for industrial and or commercial applications as well as just residential.
Cool.
So, part of our program is we are, in order to produce the panels, we have to be part of a third-party QC program, which means that we have quarterly inspections. All of our materials have to be inspected, weighed, measured, make sure that they fit and are within tolerance. The materials that we use are all tested pre-hand, so all of our materials have a certification before we get it, and then we have to create a certification for the panels themselves. Our OSB sheathing comes in and it has a structural stamp on it. It's a structurally graded material that's actually designed for panels. It has, or for SIPs I should say, because most OSB or oriented strand board, all of the strands of the material run vertically in the panel. So it might be a little difficult to see, but you can actually see the strength axis. They have a label on this particular one. The strength axis is vertical, so this normally would be standing upright in a typical building. With the SIP grade OSB, they take about 30% of the material and rotate it sideways, so that it actually has structural strength both vertically as well as horizontally, and it allows us to build an 8x24 panel, lay it on its side, and it still has structural characteristics that can stay there and support the roof or the floor system above.
Wow. Learn something new every tour. This is great.
So all of the materials come in. It's all verified or stamped before we get it, and then we run it through the process of assembly. Running the glue through, or running the foam through the glue, adding the moisture, running it in through the pressure in the presses, and allowing it to cure. The only thing that we can really test after the fact is that our glue line was good, and that's really the only thing that we can control, making sure that we have the right amount of adhesive going onto the foam, and then making sure that the adhesive is reacting correctly and curing properly. So we have a little pull test that we created that we will pull a sample, 12 by 12 sample out of a panel as we're cutting it, and just run it through here. And this helps to verify that our foam is structurally sound, and that the beads were adhered properly during the process of expansion. And it also kind of verifies that the OSB is good, that it's not just going to flake apart. But primarily what it does is it tests our glue line in the process. So what it is, I just fastened these two plates onto this one panel. So this is just a 12 by 12 block, 6.5 inch panel, and we're going to set it up in this machine. It's going to pull it apart, and we'll check the the pressure that it takes to actually pull the panels or pull the skins apart from each other.
And it's conveniently per square foot, right? Because you're
And it's
using
per
a.
square foot, so it makes it really easy.
Yep.
So we're going to start off at about 200 psi in this system. And so when we pull these, the EPS foam is going to be the weakest link of the entire assembly. And we know that the 1 pound density foam has a tension or tensile strength of 16 psi is the minimum, which when it gets put through this machine would be approximately 560 psi of pressure pulling it apart. So we're going to start at about 200. We're going to set the lever down. It's going to start pulling, and then I'm going to slowly crank up the pressure and see where the foam actually pops.
Cool. Which will be exciting and explosive, yay? All right. Oh, hello.
We're right about 600 psi, so it falls within the range that we would normally expect the foam to run, which is 560 to about 700 psi. Turn this off.
Wow, look at that. Oh, I can see some of the screws poking through
Yeah.
on that bottom one. Huh.
And so what happens is, this is to be expected. It's going to break in the foam. If everything works well, it's going to break in the foam. And usually, it's very difficult to see, but you can actually see where the glue has penetrated up into the foam beads themselves, into the cavity of the foam. And that gives us a good indication that the adhesive was working properly. Because it does expand in pressure, and once the moisture it's in contact with moisture, it bubbles up and it fills all the little voids. So these little pockets of yellow in here are exactly what we want to see. We verified that the OSB held up well. The screws go through the OSB, so it's really just the tension on those screws. The beads did break, or the foam beads did break, and like I said, that's normal. That's what we would expect. And we want to see it break somewhere in the middle of the panel, or the middle of the block of foam. Anywhere from 1.5 to 2 inches. This is a little bit thin, but not. It just happens. It might have pulled a little tighter on one corner than the other.
Cool.
And the other half of it is, just a duplicate.
Yep.
So
Nice.
go right back. And so then we take that number. So this one popped at about about 620 psi, and we'll take that number and record it on the blank, and then record it on our pull test data sheet.
Cool. And that is I love this apparatus. That is a homegrown apparatus, right?
It is, yep.
Nice.
The presses are all in-house designed, and
yeah,
it's
that's
worked out really well for us.
the cool thing. There's so many innovations in your production process that you yourself designed.
It actually is perfect timing because we just did our quarterly QC today. Had to do a video conference. And although it's all upside down, you can see once a quarter we have to build a panel and then cut it into little beams. So 4 foot by 6 inches wide, and then the 6.5 inch panel. And we ship those 5 pieces off to our testing lab out in Indiana, and they will put it under pressure and break it. And what they do is they take the end of the beam, they support the end of the beam, and then they put a hydraulic piston on it, and it pushes down in the middle, and they see where it snaps and they have designated values that the panel as an assembly has to meet, similar to ours, but they're doing it in compression instead of in tension.
So they literally do a bending test on that as a beam.
They do a bending test
Cool.
on each one of these pieces as a beam.
Interesting.
And
Interesting.
depending on the materials, with any luck, everything passes, above the minimums that we have to meet, which is same as with the tension test.